Hi class, in chapter 3 we'll be talking about methods and behaviors, and a lot of times if we think about methods we're talking about different subprograms, different pieces of a program that fit together. And I like to think of baking a cake or just baking in general, because when we're baking we have inputs that we do some processing to or upon our behaviors, and then we end up with some outputs like delicious cupcakes or delicious cinnamon rolls. And look at those, yay, yay baking. So we can think of baking a cake as kind of an algorithm. We have a series of inputs and then a series of steps that we have to follow, and when we're done we result in the output that we were hoping for. So just like any other algorithm, let me get this out of my way. So methods and their behaviors. We have a lot of objectives for this chapter. We'll be looking at the methods that we've already used in the console class and look at some new ones in the math class and talk about writing our own methods, different types of inputs or parameters that we can use for our methods, and then our chapter example is getting to be more and more important as we move through more involved and intense code. Methods are defined inside of a class, so we continue our hierarchical structure where things must be within another thing. And a method is simply a grouping of code statements or program statements. And a method can be created based on a functional need, like we need to output some instructions to our user, so we can create a method that does that. And a method could be called one time, or it could be called many times. Maybe we need to output these instructions every time the user asks for them. Now, if you remember from chapter 1, any program that we write in C# has to have a main method. This is considered a user-defined method, even though C# kind of puts it in the code for you. But it's a user-defined method in that it's something that you create. You can make it do whatever you want. In this main method, we set up a variable named a value, and we do some things with it and output it. What's important here is that our main method is a required method. We have to have it somewhere within our solution. Now, just like any other method, this main method is created with a certain set of syntax rules. So first, in our main method, we have the static modifier. We have a return type of void. We have the method name of main, and we may or may not have some parameters within the parentheses. Whether we do or not, we still need the parentheses because they indicate in other places that this is a method. Then our method is going to be followed with an open and closing curly brace to indicate the body of the method. So these are some syntax rules. We could put those in our OneNote notebook. I'm going to add a new tab here for chapter 3, methods and behaviors. And I want to have some notes and some syntax. And I'll go back to my note and say a method is a logical grouping of program code. And a method is called to execute it, and a method is reusable, so we can call it multiple times. Now in our syntax section, we see that we started out with a modifier, then a return type. Is that right? Let's check. If I go back to my presentation, modifier, return type, method name, and then we have some parameters. Then an opening and closing curly brace. So this is our syntax for a method. So let's do our main. We start out with that modifier static. We don't return anything, and our method name is main. This is a standard method. We use the main in lots of places, so it would behoove you to kind of commit it to your memory so that you could type it if you needed to. Now again, within the curly braces is the body of our method, and in this case it's our main method. Now those modifiers, what are they? They're in method headings, and we can also use them when we're talking about classes or other class members, and we're saying how this thing can be accessed. We have two types, either the keyword static or a type of access. So let's put that in our notes here. My notes, I'm going to say that modifiers appear in method headers, appear in class declarations, indicate how it can be used, and we have two types, the static and access. Now the access modifiers we'll see are often going to say things like private, public, or protected. So these are our different types of access modifiers. The word static says that this member, this method, belongs to the type itself rather than to a specific class. So our main method has to include the static keyword. Whenever we have a static modifier, the instance method that it's associated with requires an object. So some examples. Members of the math class are static, like the power method. Whenever we run the power, we don't have to create an instance like, say, new power equals this and this and this, and we'll see more of that in other classes. We can just say, using the math class, run the pow function. Or using the math class, run the square root function and pass in a parameter of 25 and give me the square root of that. The access modifiers, you can see I just listed a few, tell us who can access our code. Can anybody access it? Can only other pieces of code within our solution access it? Can it only be accessed within itself in its own class? Really private information that we want to keep private. So we'll see how those access modifiers work as we get more experience. But basically, we can give ourselves an overview here. Now, this is a great opportunity to show you how to grab something, a screenshot, into your OneNote notebook. I wanted to show you how to do this. I have my modifiers information here on OneNote, but if I wanted to insert this graphic from the presentation, I could use the Insert menu, and I could say I want to insert a screen clipping, and then eventually it'll tell me to grab the part of the screen that I want. I'll say, oh, I want this. And now I have that within my OneNote notebook. I can use Shift and resize to try to make it a little bit more manageable of a size. And of course, I could always resize it before I clipped it if I wanted to make sure that I was getting something of a certain size. And I'll resize it, make it nice and small so that it fits in my notes. Now my Shift key will try to keep it from getting all stretched as much as possible. And there we go, and I've got my screen clipping note right here. I'll keep with it, when that was taken and how I got it and all those kinds of things. So I can really easily add more information and graphics to my OneNote notebook to keep track of all my C# information that I need. Now, whenever we are working with our methods, we have parameters that we're going to use as input But we have several ways that we could output from our method. Our method could use the write or the ReadLine method to output things to the console, or it could return a value to its caller, like maybe it did a calculation and it wants to return the answer to the calling method. So we can do that with a return statement, and a return statement has some really simple syntax. It says return space whatever needs to be returned, the variable name or a value. So whenever we're creating a method, what type of data we're going to be returning from this method is going to indicate our return value data type. When we say void, we are not going to have a return statement in that method. In this case, we have a method that calculates the miles per gallon. So its inputs are an integer that it's going to call miles traveled, and a double that are the gallons used. It's going to take that miles and divide it by the gallons that were used, and the result of that division is what will be returned. Now, because one of these variables is a double, the result of that division will be a double, and so we'll be returning a double value from this method. So in our method header, we specify the return type of double instead of void, so we can see where that comes from. Now, when we're creating our methods, we need to be concerned about standard method names. We have some rules. Methods in C# usually start with an uppercase. They're usually action-oriented, like calculate or assign or display. So we want to make sure that our method names are descriptive of the action that's going on within. They use Pascal case. We don't see a lot of underscores and things like that like we might in some other programming language, not in our C# method names. Now, within our parentheses for our method, we're going to be specifying what kind of input the method requires, and we'll specify that input as parameters. And parameters are going to say, I require this information to do my processing. Now, when we declare a parameter, we have to say what type of data that parameter is and give it a name. So it's basically taking the place of the definition statement of a variable, because that variable will automatically be allocated and assigned a value based on the data that's passed in to our method. So we can have different types of parameters. We can have formal parameters, and those are the parameters that are listed in our method. And then the actual arguments is the actual data that's being sent at runtime. So let's think about this. We have this method here called calculate miles per gallon. It expects these two inputs. It returns a double. When we call this method, we're going to name it. So we're going to say its name, say my name, and here it is in bold. So we have this big C# statement here. We've said I want to write an output line, and the string I want to output is miles per gallon, and I want a parameter value that's a number that I want displayed with 2 decimal places. Now, where should I get that number from? Well, I should get that number from whatever is returned by my calculate miles per gallon method. Now, when I call calculate miles per gallon, I'm going to pass in how many miles I traveled and how many gallons of gas I used. So that's what these two numbers are in the parentheses. So now these become the arguments, the actual data that's being sent in to these parameters. Notice that the arguments have to be in the same order, the same data type as the parameter definition in the method. When I create a method, I don't have to have parameters, just like I don't have to have a return statement. But if I don't have any parameters, I don't have to do anything special. I just leave my parentheses blank. I do still have to have the parentheses, but I don't put anything in there. Now when I create my method, again, my method body is including closed in curly braces, and inside that method I can declare variables, I can do all sorts of work, I can call other methods, I can basically do anything that I could do from within my main method. And then when I'm all done, I can issue a return statement if I like to return some data, and that will end my method's execution, or I can just run out of lines of code and hit that closing curly brace, and that'll end my method execution. Now, when we call a method, we saw that we just put the method name and then we follow it with a list of argument data within parentheses. But if I have something that doesn't return a value, I can just call the method. The qualifier is optional. That's going to be my class or my object name. IntelliSense will help you a lot when you're working with this, especially at first, because as you start typing, it'll give you options in the drop-down list to tell you what kind of methods are available. For example, if you type the word console followed by a period or a dot in an active code window, IntelliSense will drop down with all of the methods and properties that are available to the console class. We can see that we have these two methods shown with the purple 3D box of write and ReadLine, and as we mouse over them, IntelliSense will try to give us even more helpful information about those methods, what kinds of things it wants to be passed, what kind of inputs are required. Predefined methods are methods like those console methods that exist in the C# library. We have a lot of predefined methods. We've seen some of them working with the console class. We've even seen some overloaded methods where we could have methods with the same name, but those methods can have different names or different types of parameters. For example, if we look at the write method in the console class, it says there are 18 different possible ways that we could call the write method. One of those ways says we would pass a string in, and that would be displayed on the console. We could use these arrows to look through all of the different formats that are available for the write method to see what all of the different overloads are. Now the read method, conversely, is not overloaded. It always just reads in an integer. So if you type the letter K, it gets pretty mad at you. But different methods do different things. So here's our read. Notice it doesn't tell us that there's any overloads in the IntelliSense, but it is still helpful in telling us what we need for that read method. Here's an example where we are reading in a number from a user. So we're going to write out the prompt, enter a single character, then we're going to do the read command to read in whatever character they type. Now at this point, we'll just output that and say, here's whatever they typed. So if they typed in the letter A, notice that because Visual Studio and C# are bound and determine the read only reads a number, it's going to convert it using that Unicode code table to a Unicode equivalent number. So the number 97 in the Unicode table is equivalent to the letter lowercase a. Now we could take that number and cast it back as a char data type by using casting. If you remember, that's where we put the data type within parentheses, and then we would see the actual letter A. So try some different things. ReadLine is another option for us to read data from the console. It reads all of the data up until the pressing of the enter key, so it expects that data to be a string. No overloads. It always returns a string. ReadLine is more versatile than read, and it returns all the characters up to the enter key, but it always returns a string. So we have to parse that string to determine if there's a number in it. What's parsing mean? Well, that means taking something and putting it into different pieces. So for example, I could be asking for an age, and I can write out a prompt to enter your age, and then the ReadLine statement reads whatever string the user typed in up until they pressed enter into this variable, a value. Then we're going to use the parse command and say, we want to take whatever is in a value, and we would like to parse that as an integer and put the result into our age variable being an integer. So that parse statement is kind of like a conversion. It says, oh, okay, I'll take this input value that's in parentheses and I'll turn it into an integer or whatever data type is before the call. And I can output this information as a number. So the read key, we use it to hold a string. It just reads in the next character entered by a user. We can use it if we like. It's not overloaded. We can call parse then if we want to, and we can say we want to parse something into a double. We want to parse something into an integer, which we saw in our example. We could parse something into a char data or a Boolean. No matter what, our parse expects a parameter value that's a string, and its output will be that value converted into whatever data type we specify. There's several examples in your textbook. Now, another way that we could change data from one data type to another, we've seen a few. We've seen that we can cast things. We've seen that we can parse things. Now we'll see that we can use the convert class. The convert class gives us another nice simple way to convert things from one data type to another. So I can convert something to a double, to a decimal, to an int 32, to Boolean, or to char. So in this example here at the bottom of the slide, I have an integer named new value. And by the way, I can declare my variables like that in line with a line of code. And I want to set that variable equal to the string that's in my parameter value converted to an integer. So it'll be a 32-bit integer. And that statement then will take that string and convert it to that desired data type. Besides the convert class to work with data, we might want to work with the math class. The math class gives us lots of math functions, and we can use them for many different things, many different calculations. Absolute value, ceiling, and cosine, and exponential, and what's the maximum. Lots of options. Let's look at some examples here. Here we have a value that's 78.926 and a couple double variables to hold output from math calls. So first we're going to use a value as input into the floor method of the math class. The output from that would be 78. So we would just truncate that number at the decimal place. Floor does not do any rounding. The second call is a call to the square root function. And here we're saying that we want a value to be input into the square root method of the math class. And the output from that should be placed into the variable result too. Now, when we're doing our square root, we are going to get some decimal places depending on what our input number was. So notice how these work where we are saying I want to call the math class and I want to use a given function, and the parameter that I want to pass is this certain value or calculation or expression or whatever we want to use as input for that math function. The output then from the math function will be saved in the variable named to the left of the equal sign. This example gives you some good code, some good things for you to try. Now, when you write your own method, you're going to use the same naming rules that we've seen in our main method. You're going to start with modifiers, return type, then name your method, and then within parentheses, the list of parameters for your method. Now, the void methods that don't return any data are the simplest to write. We don't have any return statements. So here's a nice method called display instructions. It doesn't really do anything other than write out these lines, our instruction lines. So it's an important method but it doesn't return any values. It doesn't do any calculations. It's just a whole series of ReadLine statements. That's fine. It serves its purpose. It has its function to display instructions. Now we have some other methods in our carpet calculator application that's presented in the chapter that can do more things, like do calculations and other things. This method is another method that doesn't return any values, but this method requires some input. It requires a double value that it's going to call square yards, and it requires a double value that it's going to call price per square yard. So any other program or method could call this method. It just needs to pass into the method two double variables or values, and then this method will do its work. And our caller doesn't really need to know what that work is, right? It's kind of a black box. We don't have to worry about it. But what our display results does is use those input values to format some nice output about our carpet calculator. Now, we can also write a method that returns a value, and that's going to have a return type that's not void. The return statement has to be compatible with data being returned. Now, in this type of method, again, we can have no arguments or parameters or 1 or 2 or however many we want. And we can place calls to this kind of method in assignment statements, in output statements, in math expressions, or any place that we could use a value in C#, because we're going to get a value returned from this method. So for our example, our method called getLength, the value that's going to be returned is a double. It does some calculations here, and finally at the end it says return the results of this calculation. So again, our calling methods don't need to worry about what this method does. All they need to do is be aware that they're going to have a double value return that's going to be the result. Now our carpet cleaning example is expanded in this chapter, yet it's critical that you go through that so that you can see some additional information. They're going to show you some different types of parameters that you can use. We can pass by ref, we can use output parameters, or we can use named parameters in our calls. These are all really, really important options. So be sure to look at the examples and do some testing so that you can see how things work. As an overview, by default, when we pass a value as a parameter, we're going to be passing by value. That means that when my main makes a call and it passes in a test value, that value will not be changed by calling that method. My test method will get the value, change it, do whatever it wants to with it, but it'll only affect it locally, its own local copy of that value. When we return back to the calling statement, continuing on in our calling method, our parameter will not be changed. Now we can pass by reference, and that's a little different. In that case, when we pass a value, we're passing the address of that value, the memory location. So the method that we call is working on the same exact value in the same exact location in memory. So when that method is complete, our value is updated based on that method's updates. Now a third type that's a special type available to C# is the out parameter. And in an out parameter, we can say that we have a value that's not been set up yet, but our parameter is going to be initialized by our method. And in that case, we would say out test value, and our updated value would be available after our method call. I've shown you guys how to use that. We can assign parameters by name when we call a method, and this is a really great way of doing things where we can say that we want to pass a certain value in, and we can say that we want these named arguments so that we don't have to worry about what order we pass our parameters in. You may not see this often in C# code that you're maintaining, but it is a great way of programming where we're passing by name to arguments instead of by parameter location. Now there's a lot to get a hold of in your mind in Chapter 3. Do as many exercises as you can. There are some videos that walk through doing that carpet calculator. Think about changing any programs that you've already written to use methods, an input method, maybe a processing method and an output method. Anything you can do to practice. There is some practice available for you in some other places that's posted on Canvas. So have a good time with it. Enjoy getting everything all logically organized. Thanks.